Hello students, welcome back to MathsGenii. Today we're going to start with a very interesting topic. But before we start with this topic, I recommend that you watch the limits video that we have uploaded first and then watch the video on continuity. So this topic, continuity and differentiability. So we will first see what continuity means with respect to limits. Okay, so that's very important for you to see the video of limits in order to understand this particular video. Okay, so let me just take you back to limits first. Even before we understand what's on the screen and what I have drawn, what is this graph all about, let me just remind you of the concept that we had learned in limit. When does the limit exist? The limit exists when the negative side of the function and the positive side of the function are the same. So C plus and C minus represents that. Okay. This is the condition for limit to exist. Okay. So in detail, if you want to see derivation, you can always go back to my limits video. Now, limit exists in this situation. So now clearly for less than 0, for this value less than 0, the limit value is 1. For x greater than 0, that is the plus sign. So for x greater than 0, the value is 2. So clearly, forget continuity, even limit is not existing here. So let me take you to another example. Now, if I say that I have a graph in which the value is 1 throughout, that is the value. So you look at this function, right? This was your function. So I'm rewriting this function for continuity. I'm just explaining how continuous function looks like. Okay. So if I rewrite this graph as f of x is equal to 1, 1, 1. This is just a situation to explain. Okay. You're not going to get such straightforward questions in exam. And at x is equal to 0. For all these three values, if the function is the same, if the function is giving the same value for all these equations, for left hand limit, for right hand limit, and at x is equal to 0. So now in continuity chapter, you are going to call this inequality that you get in the question, you're going to call this 0 as C. So this is a very important question, the point of continuity or the point of discontinuity. So this is your C. This is the variable that you got to keep in mind. Okay. Now let's look at the official definition of continuity. Suppose f is a real valued function. For example, in this case, f of x. F of x was the real valued function. Okay. On a subset of real numbers, of course, and let C be a point in the domain. So 0 was a point in the domain of this function C. In our case, in the previous example, the C was 0. Okay. Then f is continuous at C is if. So this is the condition that we are going to follow throughout the chapter. So they have not written C minus C plus separately, but this is what is understood, correct? This is what is understood. So if right hand limit, so more elaborately, if left hand limit, right hand limit, and the value at x is equal to C exist and is equal to each other, then f is said to be continuous at x is equal to C. So what is he saying? Left, right, and value. So that is what I was showing in this graph. Left, right, and the value. At this time, we can claim that yes, the function is continuous. Okay. So as you solve more and more example, it's going to be very clear to you. Okay. Let's look at this example. Check the continuity of the function f given by, and the point of continuity given to you is x is equal to 1. So now what I have taught you is, firstly you have to see left hand, you have to see right hand, and you have to see at that point. So your condition will satisfy when limit x tends to 1, because you have 1 here, 1 minus f of x is equal to limit x tends to 1 plus f of x. This combined is nothing but this, okay, is equal to f of c. So in this case, your c is what? 1. So if this condition is satisfied, then your function is continuous. Now you got to remember two things when you find the left hand and the right hand limit. So while you're finding the left hand limit, c is the point of continuity, and if you remember, in limits we had something called as h tending to 0. Okay, so this h from limits. So if you want to understand this in detail, you can again go back to my limit video. So for the chapter continuity, you got to remember when you have this minus, that is the left hand side, so you got to substitute c minus h in place of x. You got to substitute c minus h in place of x, and for the positive side you got to substitute c plus h. Now it's very simple, you will see. And why did I introduce this? So in this example, it's not very essential to use this, you can always solve it in a shorter way, but still I'm introducing this because it's a standard method that you will carry in all the questions and you will not get confused. Okay, so I have limit x tends to 1 minus, what is your f of x? 2x plus 3, correct? Now can I rewrite this question in terms of h? Limit h tends to 0. Now this is the minus side we're talking about, so what are you going to substitute? C minus h. C is what? 1. So 1 minus h plus 3. So now instead of h, I'm going to substitute 0. Then the limit sign will go off. 1 minus 0 is 1 only. So 2 plus 3 is 5. So this first is sorted. Okay. Now this is sorted. Now let's look at this. It's the positive side. It is the right hand limit that we are talking about. Okay, again, now what did I suggest? That you have the positive side, you want to substitute c plus h. C is what? 1. How did I understand c is 1? They've given in the question x is equal to 1. So that is the point of your continuity. So that is your c. C is 1. So 1 plus h I'm going to substitute. First I'm going to convert this x into h. Limit h tends to 0 to c plus 1 and the function as it is. In place of x I have substituted this. Now again remove the limit sign and substitute 0. So what are you getting? 5. So come on, right hand and left hand limit are equal. Now what remains? F of 1. So you have to find f of 1. So your f of x in the question is 2x plus 3. How do you find f of 1? The most simplest of all. Just substitute 1. What do you get? 5. So here you have 5, here you have 5, and here you have 5. So all these three places you have 5. What does that mean? The function, yes, the function is a continuous function. Okay, I hope with the example it's super clear for you guys. Okay, now let me show you some interesting proof or interesting theorem that the chapter continuity has. It's called a fog. Now don't get very overwhelmed with the term. It's a very simple question or a simple theorem. Fog, what is fog? F is a different function and g is a different function. So let's understand with an example. If you have one function as say sine x, okay, sine is your function x, okay, and you have another function g of x called x square. What is the fog or or fg of x? You can call it anything, okay, I prefer calling it this way. So instead of this, in the f of gx function, you will have this. So this is how the function is made. Now in terms of continuity, how is it used? Now, what does the theorem state? It's a very interesting part again. It states that if your f is continuous, okay, if f is continuous, if your g is continuous, then your f of gx is also continuous. Let's understand it in details with one example. So, uh, if g is continuous, if f is continuous, then f o g is continuous. So this is your sin x. This function is your sin x. It is continuous at all points. Okay, sin x is a continuous function. This is your x square. X square is also continuous at all points. Take any point at random. Now this function that you see at the bottom is nothing but sin x square. So if this is a continuous function, then f of gx is also a continuous function. Simple. That is what the theorem is telling you. It's that simple. Okay. Now let's look at one more example of the same theorem. Okay. Now, what does it ask me is, prove that tan x is a continuous function. Now we all know that what is tan x? Tan x is sin x upon cos x, correct? Now sin x is a continuous function, correct? Cos x is a continuous function. So therefore tan x is going to be a continuous function except when sin x upon 0. Anything upon 0 is not defined. When does cos become 0? Cos becomes 0 at I'm assuming that cos becomes 0 at pi by 2 will be your immediate answer, correct? But all the multiples, so here I hope this is taught to you in 11th grade. This is trigonometry, but I'm just revising it quickly. So all the values, when cos will attain this value, the cos will become 0. If you put 0 here, for example, so 2 zeros are 0, 0 plus 1 is 1. So 1 into pi by 2 is pi by 2. So at cos is equal to pi by 2, your answer is 0. This was one example. Instead of n, now if I put 1, so 2 ones are 2, 2 plus 1, 3. So 3 pi by 2 will be your another value. First value was pi by 2. So for all the values so on and so forth which are going to satisfy this equation, cos becomes 0. So the function becomes discontinuous at this point. Okay, very simple. Now let's the major theorems we have covered. Now let's look at more and more examples so that it becomes crystal clear for you guys. Okay, again I have written c minus h, c plus h just to remind you guys. So this is the very first question from your textbook, which says f of x is equal to 5x minus 3. Examine the continuity at x is equal to 0. Okay, now what I have taught you is you have to find three things. Immediately write down what are the three things that you have to prove. When is this function going to be continuous? It's going to be continuous when limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 0. That means f of c. So this is your general point to prove continuity. It's going to be super simple. So I'm just writing it in a very shorter way. Instead of this, I'm going to write limit. I'm converting this. Okay, let me not, and I'll do it in a slower manner. Okay, instead of f of x, I'm just writing what f of x is. Okay. Now I'm converting this into h. As I have taught you, your second step should be convert in terms of h. Okay. So limit h tends to 0. So all h tends to 0 is a standard term. If you remember, in the previous question also we had 1 minus, but we had converted into 0. Okay, so every time you're going to write h tends to 0 because that's the definition of limits. Okay, then 5. Now for minus, what I have said is it's c minus h. In case of this question, your c is 0, and here for plus it's going to be this. So 0 minus h minus 3 is equal to limit x tends to 0 plus 5. In if whenever you have plus, you're going to write c plus h, which is 0 plus h minus 3. Okay, then you have, now instead of h you're going to substitute 0. Okay, instead of h you're going to substitute 0, so the limit sign is going away. So it's going to be 5 minus 3, it's 2, and this is 2. So this and this is satisfied. Now what remains is finding f of 0. How do you find f of 0? Firstly, what is your f of x given in the question? What is your question? This. What do you want to find? F of 0. Most easiest part. 5 minus 3, it's 2. So here you have 2, here you have 2, here you have 2. So thrice you have proved that yes, it is equal, and that is why it is continuous. Very, very simple. Now pay careful attention to the next question. It's going to be might be a little bouncer if you don't pay careful attention to this question, because this involves mod. Okay, and how I am solving this mod, pay careful attention. Okay, now whenever you have mod, okay, forget this. Let's teach you what to do when you have a mod. So forget everything. Just imagine that you had this question. Now why do we use mod? So that any number in the mod, if you had minus 3, when it will come out, it's going to be plus. So why do we use mod is to have to obtain, to in I'm talking in a very layman terms, okay, to obtain a positive answer. Okay, a positive answer or a positive value. Okay, that is the aim of mod. Now how mod is expanded. So you have a number line. In the number line, you have 0, this is all the negative value, and this is all the positive value. So this is going to be all the values of x less than 0, and this is going to be x greater than 0. So for how is it expanded is, it's going to be for x less than 0, for x greater than 0, for x equal to 0, and x greater than 0. Now when you remove mod for x greater than 0, it's anyway going to be positive, correct? If I remove mod for a positive number, it's going to be positive only. So mod x will remain x only. Even at x is equal to 0, it's going to remain positive only, or it will become 0. See, at x equal to 0, if you substitute x is equal to 0, it will become 0. Now the catch here is, what will you do for x less than 0? For x less than 0, you're getting negative. Now what will you do? So I'm going to write here minus x. Now understand why I'm writing it as minus x. If you have a number, so what is my aim? Aim is to obtain a positive answer. Okay. Now if I have a number here as minus 3, my number is minus 3. So if you put x in, if you put minus 3 in place of x, it is going to be this minus, and then minus 3, it's going to become plus. Hooray! That was my aim. My aim was to bring a positive value. And how did I bring a positive value? By adding a negative term. So my thing was retained, right? It was a negative side For negative side, I wrote minus x. For 0, I wrote 0. And for positive side, I wrote plus x. So this is how you expand mod x. Now, this entire story I narrated just for one step. Here you have x less than minus 3. So you have less than. So this mod x, when you remove, will become minus x. Why minus x? Because of this entire story. Because x less than, x less than. For x less than, what do you write? Minus x. For x less than, what do you write? Minus x. So I'm rewriting this question. So I hope you have followed the entire story of why we had to rewrite this question, because you cannot go ahead without rewriting it. This is going to be minus x. Okay. Now that we have rewritten the question, that we are in position to solve it. Okay. Now you have 2 points here. Observe. You have 2 c's here. Okay. You have 2 c's here. It's minus 3 and plus 3. Correct? Now, at first, let's look at x is equal to minus 3. So for now, your c is minus 3. Okay. And what I have taught, remember, I have taught you c minus h and c plus h. So it will become minus 3 minus h. In place of x, you have to do all this. Okay. We have done this enough in previous 3 questions. Okay. Now, again, what you have to prove? Left hand, right hand, and the value at c should be equal. 3 things you have to prove. Left hand minus 3, the negative side. Okay. Then plus 3, the positive side. Okay. Now, what I have taught is the second step is change into h. Change this into h tends to 0, the standard definition of limits. What is your f of x? For x less than 3. So this is the negative side, right? For x less than 3. Less than minus 3. X less than minus 3. What is your f of x? It is minus x plus 3. Instead of, okay, let me just go slow. Okay, let me just rewrite this. What is your f of x for x less than minus 3? It's minus x plus 3. Okay. Now, limit. Now convert it into a standard h form. Okay. For standard h form and for minus, what I have taught you is this. So I'm going to write, instead of x, I'm going to write minus 3 minus h plus 3. So now we are going to get rid of this sign, h. So instead of h, what am I putting is, this minus minus becomes plus. This minus minus becomes plus. H, instead of h, I'm putting it as 0. So you have 6. Okay. This was for minus 3 raised to minus. That is the left side. This was your LHL, left hand limit. Now RHL, right hand limit. Limit x tends to minus 3 plus. So any value greater than minus 3. Go to the question and find out any value greater than minus 3. So we are going to consider the function as minus 2x. Minus 2x is greater than minus 3. Correct? It is greater than minus 3. So your function is minus 2x. Now, what is your second step is convert it into h tends to 0. Now for plus, what is the substitution for plus? Minus 3 plus h. Minus 3 plus h. So again, let me just open the bracket first. Minus 2 minus 3, it's 6, minus plus minus 2h. But limits tends to h0. So instead of h, I'm going to substitute 0. So it's going to be 6. Okay, so two things I've proved. Now one last thing is remaining. At x equals to minus 3, that is f of c, I have to find f of c. That means I have to find f of minus 3. At f of minus 3, what is the value? And then if I get that value, only then I can say that yes, limit exists. So at minus 3, what function I will choose? Out of these three functions, what function will I choose at minus 3? So at minus 3, you have only one value. This is less than equal to minus 3. So this is the function I'm going to consider. Okay. So it's going to be minus x plus 3. So your function is minus x plus 3. How do you find f of minus 3? This is your f of x. How do you find f of minus 3? It's the most simplest of all. Just substitute the value in place of x. So minus minus plus. So this is 6. So previous two values you got 6, and that is how I say that yes, the function is continuous. Similarly, I did this for minus 3. You have to do it for plus 3 and check if it is continuous. Do let me know in the comment box if you get it as continuous or discontinuous at plus 3. Okay. Moving ahead to the next question. Discuss the continuity of sine function. So this is kind of a derivation kind. Okay. Now we have to discuss the continuity for a sine function. Now, how does a sine function look like? Sine x, correct? So this is your f of x. Now I have to discuss the continuity of this function. So you have limit x tends to 0, sine x is equal to 0 as your starter. Okay. This is a fact. Okay. We don't need to prove it. So now what I have always taught you is change into h. Always change into h. Okay. So limit h tends to 0, sine of, if I have to change this into h, what I have taught in the previous questions, either you use c plus h or c minus h. So we are considering the right hand limit. So I'm going to use c plus h. So substituting c plus h. Okay. Now let's see what and where this function is taking us. So one thing you guys know is sine of a plus b. It's sine a cos b plus cos a sine b. Correct? So in this case, your a is c and b is h. So your answer to this question is going to be limit h tends to 0, sine c cos b plus cos a sine b. Correct? Now always, if you want to find out the limit, you can, this is a plus sign between, so I can break the limit. Quickly breaking the limit between these two. Sine c into cos h. You have to write this in full form in the exam. Okay. Limit h tends to 0, cos c into sine h. Okay. So now in place of h, you have to substitute 0 in order to remove the limit. correct? So you will have sine c into cos 0 plus cos c into h. In place of h you are substituting 0, so you have sine 0. Then what is the value of cos 0? Cos 0 value, go back to your trigo table, cos 0 value is 1, correct? Then what is the value of sine 0? Go back to trigo table, sine 0 is 0. So this entire term, anything into 0 becomes 0. So your answer is sine c, correct? And this is one part, okay? And what is f of c? This was your f of x. Sin x was your f of x. By the way, this was your answer of limit, right? Limit h tends to 0, h tends to c, or limit. So the original function was actually limit x tends to c, f of x. Now if you want to find f of c, so you just have to substitute c. F of c is equal to limit x tends to c f of x. Therefore the function is continuous. This is the condition when we say the function is continuous, and we have proved it. Okay, I hope you have gotten this. You can always rewind and check. I've given explanation of each and every step. Okay, now coming back to the next question, which is, now carefully see, you don't have to be a master in mathematics to understand this. At x is equal to minus 5, if you put at x is equal to, so the function is discontinuous for sure at x equal to minus 5. If you put minus 5 here in place of x, what do you get? 0 upon 0. 0 upon 0 is an undefined form. So we will check if this is not defined, this function is not defined at x is equal to minus 5. So let's check the continuity at any point other than minus 5. So we don't have a point. We don't have a point. In all the questions you had x is equal to 1, x is equal to 2. But you have here x not equal to. So we will consider the point as x is equal to c, and then we will check the continuity. Understood? I'll just show and go back to the previous questions. So here you had x equal to minus 3. So I considered this as c. Then in the previous question, yet x is equal to 0. So I considered this as c. But when you come at this question, you don't have a c defined. Okay. And plus what they have given. On that point, the function is not defined only. So I will consider a random point s is equal to c. Now to check continuity, what is the formula, or what is the rule? It's this, right? We just checked it in the sine question. So for all the proof that question, you can assume x is equal to c, like I had assumed in the sine question. Okay, so firstly we will check this condition, then we will check this condition. Okay, so the condition says limit x tends to c f of x. Okay, so now what is your f of x? F of x is nothing but your question. It is x square minus 25 upon x plus 5. Now you cannot directly solve it. Can I write this 25? Can I write this 25 as 5 square? I can write, right? 5 square is nothing but 25 only. So now this looks like what formula? 8th standard mathematics. A square minus b square is equal to a plus b, a minus b. So a plus b, a minus b upon x plus 5. So x plus 5 gets cancelled out. Now in order to remove this limit, I'll have to substitute. So in place of x, what will I substitute? C. So c minus 5 is my right hand side of this question. Now what is the left hand side? F of c. F of this right hand side I've found. Now I will find the left hand side also. I have to find f of c, correct? So how will I find f of c? In the question, just substitute wherever you had x, just substitute c. So you will have c square minus 5 square upon, instead of question x, you will put it as c, correct? Again the same formula, a square minus b square. C plus 5, C plus 5 gets cancelled out. What remains is C minus 5. Did we get C minus 5 here also? Yes, I got it here also. So can I say that the function is continuous? Yes. Yes, the function is continuous. Okay, I hope you guys have understood. This is the only rule which is repeating in the entire chapter, and this is how you have been finding it in all the questions. So you watched the examples that I have shown, and I think it's sufficient for you to understand the chapter continuity, because it covers a lot of variety. Now, in the next lecture, what we're going to look at is differentiability. And differentiability we will derive using continuity. So it's a continuous lecture. So don't miss the next topic, which is differentiability. Thank you, class. See you in the next video.